In this module, we are dealing with the principles of probability. And the principles of probability perhaps control several phenomena in the universe. Several phenomena occur in the universe as per the principles of probability. And we can say that the principles of probability make this world more livable by providing the chance of expecting good things in place of bad things and expecting events of different types which are favorable and unfavorable in the long run. And coming to the study of probability and probability theory, the first step is definitions of probability. And probability can be defined as the relative chance of occurrence of a particular event among a group of events. It is the chance of occurrence of a particular event among a group of events. You can say that events are the outcomes of experiments, and there are different types of experiments, and here in probability we deal with random experiments. And what is a random experiment? A random experiment is an experiment the outcome of which cannot be predicted. In the case of a random experiment, you cannot predict the outcome of the experiment. And the very common example is tossing of a coin. Tossing of a coin is a random experiment because you cannot predict its outcome. You cannot predict whether the outcome will be a head or a tail. And the outcomes of random experiments can be called random events. And example, of course, is the outcome of tossing of a coin. It may be a head or a tail, and you cannot predict the result. It may be either a head or a tail. And there are different types of events. And first we deal with mutually exclusive events. Mutually exclusive events are such events that cannot occur simultaneously. The occurrence of one event prevents the occurrence of the other event. Example is in the case of tossing of a coin once, the occurrence of head prevents the occurrence of tail. The chance of getting a head and tail together in any particular trial is nil. So you can say that the occurrence of head or tail in a particular trial of an experiment is an example for mutually exclusive events. And there are independent events and dependent events. Independent events are events that can occur simultaneously. For example, if you are tossing two coins, or if you are tossing a coin 2 times, obtaining a head or a tail in the first toss has no influence on getting a head or a tail in the second toss. So such events are known as independent events. Then comes dependent events. Dependent events are events in which the occurrence of one event in a trial affects the probability of the other event in subsequent trials. For example, drawing of a king from a pack of cards. In the first draw, affects the probability of the draw of a second card of a particular type if it is carried out without replacement. So such events are called dependent events. Here the second event or the probability of the second event depends on the occurrence of the first event. Then we come to equally likely events. Events are called equally likely when one does not occur more frequently than the other. When you are tossing the coin once, you cannot say whether the head or the tail will occur. But if you are repeating the trial for 10 times, if you are tossing a coin 10 times, you have an expectation that almost half of them will be heads and almost half of them will be tails. And if you repeat the experiment a larger number of times, for example 100 times, there is the chance of occurrence of equal number of heads and tails more regular. So you can see that if the trials are repeated a large number of times, the chance of occurrence of head or tail is almost equal, and such events are called equally likely events. And there are simple events and compound events. Simple events are events occurring singly. If we calculate the probability of occurrence of drawing a red ball from a bag containing 10 white balls and 5 red balls, the draw of a red ball is a simple event. And compound events are events occurring jointly. If we calculate the probability of getting a white ball and a red ball in the simultaneous draws of 2 balls, we call the events compound events. Or if we carry out 3 successive draws and the probability of getting 3 red balls successively can be calculated. And this is also an example for compound events. And now we move to the definitions of probability. Probability is defined as the relative frequency of occurrence of a particular event among a total number of events. The relative frequency of occurrence of a particular event among a total number of events. In a random experiment, if there are n number of events and if they are mutually exclusive, the probability of each of the mutually exclusive events is given by 1 divided by n. 1 by n gives the probability of any particular event among n number of events. And then we may move to the axiomatic definition of probability. Axioms are certain prerequisites. If there are 2 events occurring and if they are A and B, the probability of A, that is PA, is a measurable function satisfying the following axioms. Axiom 1, PA is non-negative. Axiom 2, PA is lesser than 1. There is nothing that can be defined like a negative probability or probability lesser than 0, and there is nothing that can be defined as probability above 1. When the probability is 1, the probability of a particular event is 1, such an event is called a sure event. And there are 2 theorems, addition theorem and multiplication theorem. And addition theorem speaks about the occurrence of or the probability of occurrence of event A or event B, and multiplication theorem speaks about the occurrence of events A and B together. So, addition theorem and multiplication theorem. First, let us see addition theorem. If there are two events A and B, the probability of occurrence of either A or B is equal to the sum of the probability of occurrence of A and the probability of occurrence of B minus the probability of occurrence of A and B together. And if you represent it in an equation, PA union B is equal to PA plus PB minus PA intersection B. PA union B is equal to PA plus PB minus PA intersection B, and PA intersection B is the chance of joint occurrence of A and B together, and PA intersection B is 0 in the case of mutually exclusive events. Then comes the multiplication theorem of probability, and the multiplication theorem says about the occurrence of the probability of occurrence of two events A and B together in an experiment. If there are two events A and B, and if they are independent, the probability of occurrence of A and B together in an experiment is equal to the product of the probability of these independent events. If there are two independent events, the probability of occurrence of A and B can be calculated using the multiplication theorem, and as per multiplication theorem, PA intersection B, that is the probability of occurrence of A and B together, is equal to PA into PB. And then comes conditional probability. Conditional probability is dealing with the occurrence of dependent events. If two events A and B are said to be dependent, if B can occur only when A is known to have occurred, you have to calculate the conditional probability of B on the condition that event A has occurred. And the probability attached to a dependent event is known as conditional probability, and conditional probability of B given that A has occurred is calculated using the formula PB bar A is equal to P A intersection B divided by PA. PB bar A is equal to P A intersection B divided by PA. And now let us see something about mathematical expectation. Mathematical expectation is the expected frequency of occurrence of a particular event among a number of events. Mathematical expectation is the expected frequency of occurrence of a particular event among a number of trials. If there are n number of trials in a particular experiment, and if P is the probability of a particular event expected, the possible number of times of occurrence of that particular event in that particular experiment can be calculated as n into P. N into P. Similarly, if there are two types of events expected, and if the probability of the first type of event is P, the probability of the second type of event Q can be calculated as Q is equal to 1 minus P, and P plus Q is equal to 1. Q is equal to 1 minus P, and P is equal to, of course, 1 minus Q. Now, let us see the calculation of probabilities in the case of an example. Calculation of PA, PB, PC, PA union B, and PA intersection B in the case of a particular experiment. A bag contains 16 balls, and 6 of them are red, 8 of them are green, and 2 of them are blue. Calculate the probability of drawing a red ball, a green ball, a blue ball, drawing a red ball or a green ball in a draw, a red ball and a green ball in 2 successive draws, etc. for example. After each draw, the ball is replaced to the back before the next. It means that always there are 16 balls in the bag. So in all the trials there are 16 balls in the bag, and out of the 16, 6 are red, 8 are green and 2 are blue, and you are asked to calculate different probabilities. And first we can calculate the probability of drawing a red ball in any particular trial. Probability of drawing a red ball can be called PA, and PA is equal to 6 by 16, because there are 6 red balls in the bag and 16 is the total number. PA is equal to 6 by 16 and it is equal to 0.375. PA is equal to 6 by 16 and is equal to 0.375. And then if we move to the second step, probability of drawing a green ball in any particular trial is equal to PB, and PB is equal to 8 by 16, means there are 8 green balls and the total number of balls is 16. So PB is equal to 8 by 16 and it is equal to 0.5. And then if we calculate the probability of getting a blue ball in any particular draw, of course there are only 2 balls among the 16 balls in the bag, and the probability of obtaining a blue ball in a particular draw is 2 by 16, and 2 by 16 is equal to 0.125. So here there are 3 types of events. You can say event A, event B and event C, and event A can occur 6 times out of 16, even B can occur 8 times out of 16, and even C can occur 2 times out of 16. And because of that, the probability of A is equal to 6 by 16, it is equal to 0.375. Probability of B is equal to 8 by 16, it is equal to 0.5. And probability of C is equal to 2 by 16, it is equal to 0.125. And then if we move to the calculation of probability of drawing a red ball or a green ball in a particular draw. Probability of drawing a red ball or a green ball in a particular draw. A red ball or a green ball. You want to get either a red ball or a green ball in any particular draw. So you have to apply the addition theorem. And addition theorem of probability is PA union B is equal to PA plus PB minus PA intersection B. But in this case, since the probability of obtaining a red ball and a green ball are the probabilities of mutually exclusive events. In any particular draw, if you get a red ball, there is no chance of getting a green ball or any other type of ball. So here you have already calculated the probabilities of obtaining a red ball and a green ball, and PA union B is equal to PA plus PB minus PA intersection B, and here PA intersection B is 0. So the calculation becomes 0.375 plus 0.5 minus 0, it is equal to 0.875. 0.875 is the chance of obtaining a red ball or a green ball, a red ball or a green ball in any particular draw from the bag which contains 16 balls of different types. And then you are asked to calculate the probability of drawing a red ball and a green ball in two successive draws. There are two draws, successive, and after the first draw you are replacing the ball into the bag, so that always there are 16 balls in the bag. And so you are asked to calculate the probability of obtaining a red ball and a green ball in two successive draws. And here you have to apply the multiplication theorem. PA intersection B is equal to PA into PB. And if you are substituting the values, PA is here the probability of obtaining a red ball, and PB here is the probability of obtaining a green ball. And if you substitute the values, PA into PB becomes 0.375 into 0.5, and it is equal to 0.1875. So using the addition theorem and multiplication theorem, you have now made certain calculations. You have applied the addition theorem in the case of calculating the probability of occurrence of either A or B in a particular experiment, and using the multiplication theorem, you have calculated the probability of occurrence of two events together, the events A and B together in a particular trial. So now you have come across the preliminary principles of probability. You have seen the definition of probability. You have seen the axiomatic definition of probability. You have seen different types of events, and also you have come across the theorems of probability. And the two theorems are the addition theorem and the multiplication theorem. The addition theorem deals with the probability of occurrence of either event A or event B in a group of trials, and the multiplication theorem deals with the occurrence of event A and B together in any particular trial. Thank you very much.